Hi everyone, today we will be covering some ACT science strategies for the basic question types. Knowing the question types is essential to doing well on the section. You can get a 36 even without remembering a lot of what you learned in science classes and even without having taken advanced or AP classes. So it's important to remember you need the question types and you need to practice it a lot. The first question type we'll be covering in this video is trends. Trends questions ask you how one variable changes in response to another variable. So we will be in the questions underlining things called locators. Locators are the important information that you want to locate in order to get to the correct answer. So in this one, we have table 1. Mass increases and F. So going to table 1, we want to look at where mass is increasing. That's in trials 1 through 4. We wouldn't want to look at trials 5 through 12 because mass is not increasing in those trials. And then we want to see how F is responding. So we go over to F and we see it's also increasing. So we would have answer F. Then we have the math question type. So these questions require simple calculations like addition, subtraction, multiplication, and division. And they don't require you to use a calculator. You can do estimation, and often, but not always, they'll give you a formula. So here we have our locators to begin with, table 1. And we're asked about minutes for water runoff. Looking at table 1, the water runoff is given in seconds. And it's 629 seconds. So you should know that there are 60 seconds in a minute, which would mean we have to divide this by 60 to get our answer. And we use estimation to get that the answer is 10. Then we have extrapolation questions. So these ones ask you to extend a figure or table beyond its current boundaries. They will ask you for something that's not in the figure or table, but that you can get using the trend established by the figure or table. So with this example, we have figure 1. 90 degrees Celsius, and they're asking us for the mass of NaNO3. Looking at figure 1, we can see that 90 is not on our x-axis, so we can extend the x-axis a little bit to where 90 would be. And then looking at our NaNO3 graph, which is this one here according to the key up here, we'll just extend it. And so then we can see where the graph would be. And it would be between 50 and 60 on the y-axis. Now, if you don't do the extension on paper, if you try to eyeball it, that's a little dangerous because you might see it as J greater than 60. So it's really important that you actually put it on your paper so that you can see the answer. Then we have data bridge questions. So these ones link multiple figures, and you need the multiple figures to arrive at some correct answer. Between these figures, there's some sort of bridging variable or common variable that allows you to get to the answer. So here we have figures 1 and 2. Already we have multiple figures in the question, so we know it might be a data bridge example. Resistance, device 2, 3, and then we're being asked the current, I. So because they gave us the resistance, we want to start with figure 2, which tells us the resistance. And they gave us the resistance of device 2. So according to the key, that's this graph here. And so we go to 3, a resistance of 3. Be careful to look at the y-axis since resistance is on the y-axis. So 3 is approximately here. We carry it over to the graph of device 2. And then we can carry it down to see what the common variable would be. So that's at approximately 3.2 or 3.3. So our common variable is at 3.2 or 3.3. So we're starting in the other graph at 3.2. That's here. And since we want the current, we will extend to the device 2 graph and go over to the y-axis to see what the current is. And we can see it's at 6.